Very good morning, class. Today I'm going to cover chapter 3. This will be a first part of the video on Pandas library. Okay, these are the content consist of Pandas structure, data structure, uh, functionalities on indexes, data reading, manipulation, missing values, and then some basic statistics parts, lah, generally for the plotting side. Okay. So introduction to Pandas. Pandas is a Python library that used for data manipulation. So you can see here, data manipulation and analysis. This is the reason that Pandas is very important for data analysis. Okay, it is very convenient to analyze and clean the data. And Panda libraries also introduces two new data structure to Python, which are series and data frame, both of which are built on top of NumPy. Okay, what is Pandas used for? Pandas is powerful library generally used for data cleaning, transformation, data analysis, machine learning, data visualization. And why do we need to use Pandas? It able to handle large data. It's give you a table form of data representation. It is useful for data cleaning and pre-processing. As I mentioned, this pre-processing is very important part of data analysis or data science. Okay, it plays a very major role because we must make sure that the data is properly pre-processed before we further analyze the data. Okay, next is time series functionality, and then free and open source. Okay, Pandas is free and open source as well. How to import Pandas in Python? Since we are using Anaconda, usually it already installed, pre-installed. So only thing is we need to import. Okay, in order to import, similar case as NumPy. So import Pandas as PD. So PD is the short form of Pandas. So last time we learned like import NumPy, okay, as NP, right? So for Pandas we use PD. For example, how to import, how to call how you can use pandas in your data frame in your program using PD. So PD is your pandas dot the function that you want to utilize, data frame parenthesis. Okay, let's go with the first part, pandas data structure. Pandas series. Pandas series is one-dimensional label array-like object that can hold data of any type. For example, you can see here, Panda series can be thought as a column in a spreadsheet or a single column of a data frame. It consists of two main components. One is known as label, another one is data. So in this example, in this part, this one. So this one is known as data and this one is known as index. Okay. So index means it's actually referring to or the position, or it is known also as a label. Okay, data, you know that it's a record, it's a value that assigned to that particular index or the label. How to create Panda series? So it's very quite direct and easy. So as usual, import pandas and then create list. Okay, we just create a list, data equal to 10, 20, 30, 40, and 50. So after that, we create series. Create list first, then create the series. Okay, the series is my series equal to pd dot series data. So the data is come from here. So print my series, you will get this final output. So you can see that this part is auto index, is considered auto index by default. And this is the data which is allocated. So index 0 means the value is 10, index 1, 20, index 2, 30, and so on and so forth. Okay, and at last you can see that it shows you the data types as well, which is integer 64, denotes that the series stores the values of integer 64 type. Labels. The labels in the Pandas series are index numbers by default. Like in data frame and array, the index number in the series start with 0. Okay, we know that in arrays, the the index number always start with zeros, right? So same thing is applied in data frames as well. For series, series also same. So position or index 0, 1, 2, 3, 4. So in this case, create a series from the list. So they create the series. After create the series, they want to check what is the third value. So third value is considered 1, 2, 3, index 2, right? So they just call index 2, print my series 2, and to get the output is 30. Okay, clear class? We can also specify labels while creating the series using the index argument in the series method. Okay, let's create a list. The list called a equal to 135. Create a series. After create this list, we're going to create series, and in this case, we particularly specify the labels. Okay, in the previous example, it shows you the index, okay, the index given here, okay, this one is a default index. You don't have to specify. But in case just you want to create a series with your own label or own index, you can list out, okay, you can declare it. How are we going to declare? Using this method, pd.series a comma index equal to x, y, z. So which means that x will be referring to 1, y will be referring to 3, and the last one, z will be referring to 5. Okay, so you can see that x1, y3, z is 5. Labels. To access the series elements, we use specified labels instead of default index. Since we already declared this series where these values, I mean this index, right? So this label, so x equal to 1, y equal to 3, z equal to 5. So in order to access any particular value or elements, okay, here we can use the index, this one, okay, this part. So for example, my series y, y is the value of 3. So you can see the output is 3 here. You can also create a Pandas series from Python dictionary. For example, first of all, previously we create the list. Now we're going to create the dictionary. Difference, huh? List is just a list of data. Dictionary is actually comes with the index together. Okay. For example, you can see semester 1, semester 2, semester 3. And this is the value data 3.25, 3.75, and then 3.28. Okay, these are the values. Now we're going to create the series. Okay, now create the series. You can see that my series equal to pd.series grades. Okay, the grades is come from obviously from here. So once you print, you can see this output, semester 1, semester 2, semester 3, and the values for each semester. So semester 1 assign this, semester 2 here, semester 3 is here. So these are known as the keys of the dictionary or the label. Okay, this one is known as label or index. Okay, next is the data frame. Data frame is a table-like structure, okay, which is organized in rows and columns. It's a two-dimensional data structure like two-dimensional array. For example, you can see we have a columns and we have a rows. Okay, so we have columns and rows. Huh? So country, capital, and population are the columns names, and each row represents a record with the index value on the left. So every row is created with the index, default index. Remember, this is a default index because we didn't mention any index, means it automatically gives you the default index. How to create data frame? Okay, using pandas. Okay, using Python dictionary, Python list, a file, and creating empty data frame. So let's see one by one. For the first example, using dictionary. Okay, we already learned about dictionary, right? I already show you. So the dictionary is comes with the label. Okay, in this case, the label is name, age, and city. Okay, so the name is considered one column. You can see here the output. Age is one column and city is one column. And these are the values inside the data. Okay, the data inside the column. So when we want to create data frame from the dictionary, so same thing, df is just a simple variable that anything that you can use. You can use x, y, yz, a, b, c, p, q, r, s. It's up to you as long as it's not a default built-in variables that you cannot utilize it. Okay, in Python. So pd.dataframe in bracket data. So print df, you will get this final output. Okay, this is the first method. Second method, using list. Okay, when it's come to the list, you can see there's no any label. They just list out all the data. Here only data is available. There is no any index. So in this case, we're going to create the index, okay, by ourselves. Previously, we call this as a index, but in this case, for data frame especially, we call them as columns. Okay, pd.dataframe bracket data, comma, columns equal to square bracket, and remember, open and close quote. Okay, why open and close quote? Because these are strings. When it's come to string, we supposed to use, okay, open and close single quote. So in this case, the first column will be name, second column city, third column, second column is age, third column is the city. You can see this is the output, name, age, and city. So in this example, we create a two-dimensional list and data frame function converts the 2D list to a data frame. So this one is considered 2D list. It's become a data frame, a table-like structure now. Pandas data frame from a file. Another common way to create data frame by loading CSV. We already learned about two, from dictionary, from list. Now third one is from a file. So we can utilize many different files. One of the file is CSV file. We can use JSON. We can use text file. Okay. And in this case, CSV file, import pandas, load the CSV file. In order to load the CSV file, we need to call the function or the method called pd.read underscore CSV, and this will be your file CSV file name, data.csv. And remember, open and close quote, print df. So you will get the final output. So whatever data that inside this data.csv will be printed out. Next, create an empty data frame. Sometimes we may want to create an empty data frame and then add data later. So we can add later. We just create the empty table. Okay, in this case, I just say that for your easy understanding, we just create an empty table. Okay, but it's not look like a table now, but it just shows that import panda first and then df equal to pd, okay, pd dot data frame parentheses print df, you will get this one. So this is your final output. This is considered empty data frame where they show you column is empty bracket, index also is empty. Okay, you can add later on the data. Okay, we are done with data frame. Now we'll move on to index. Index refers to the labeled array that identifies rows, columns in a data frame or a series. For example, we have, you know that this is columns and these are the rows, right? So in the above data frame, numbers 0, 1, and 2 represent the index, providing unique label to each row. Okay, we can use indexes to uniquely identify. So index 0 means we can see that the values are John 25 New York. So that is how we access the data based on index. So index will be acting as an identity over here. Next, create indexes in Pandas. Pandas offer several ways to create indexes. Some common methods are as follows. We have already teach you or mentioned about, okay, what is default index. You can set up the index, okay, and you can come out with a range of index, like certain values from 10 to 12, 15 to 20, A to B, A to D, okay, B to D, something like that. You can list out. Let's see some default index. One example, in order to create a data frame or a series without specifying an index explicitly, which means you never declare the index separately. Okay, so pandas assign default integer. Okay, index starting from zeros. Okay, let's go with the coder. So import and then the data. We know that first column, second column, third column. So create df equal to pd dot data frame bracket data. So this data will be passed here. So print df, you will get the final output. You can see. So this one we never declare anywhere in the code, but it's auto assigned by pandas. Next, you can set up the values of index. Okay, you can set up values of index from the existing column. Remember, from the existing column, you can set up one of the column to become an index. How to write this? So import pandas, data, and then call the data to create data frame. After that, you have to set using set index method. This one, set index method, df set underscore index bracket name should be open and close quote, and make sure that the name is capital N, means follow the capital N just to avoid any consequences of error. Okay, comma in place equal to true. So this in place true, it means that the parameter operates directly on the object itself without creating new object. Okay, so if you mention false, means it create a different uh, column name already. So it's not that based on the existing one. It will create, if you write false, means it will create a separate a column, which is not the existing one. Next, based on the range. We know the range means we can say that 1 to 10, 20 to 30. So these are the range, right? So we can create the range index with a specific start and the end value. Okay, start value and the end value. As usual, import and then create the data and then create the data frame. After that, df pd dot data frame data. So this data somehow will be taken here. Okay, index. See this part. Index equal to pd dot range index. R is capital, I is capital. Okay, so start with 5, end with 8. So which means there is a start and end values. Name equal to index. So the column name, it's become index, you can see in the output here. So here the range index from 5 to 8. And remember, always the end value is excluded when it's come to index. So we're only going to have three records: one, John, Alice, and Bob. Three records, right? So three records with the three values 5, 6, 7. So that's the reason we have 5 to 8. If you have a 5 to 7, you only can get 5 and 6. 7 is excluded. Since we have a three records, you have to mention 5, 6, 7. So the end value should be more than 7, which is after 7, we'll get 8. Renaming index. So in order to rename the index, we can use the rename method. For example, your original data. Okay, this one is your original data, and then your data frame. So this is your original. Okay, the first part, the first one. It just create the existing one. If you want to modify the index, okay, we use df.rename method, this one. df here, you can see here, df.rename index equal to 0, This A, 0 become A, 1 become B, 2 become C, in place true. So must make sure that it applies to that particular existing column in the table. If you never put true, put false means it cannot find the column from the table. So after you modify, you'll get this value. Can you see? 0, 1, 2, 3, 1, 2 change to A, B, C. So this is how we rename uh, the index. Next, resetting the index. Resetting the index means back to the default one. So reset the index to the default integer index using reset index method. For example, import data, create the data frame. Okay, rename index. We already first create the rename one. Okay, so this is the rename one, ABC. After that, you want to reset back to the original one. Reset index. So you have to use a method called reset index here. Okay, so in place equal to true. So you don't have to mention anything. You just write the code reset underscore index. It's auto reset for you guys based on the previous or the old data. So the output you can see here. Access rows by index. Okay, sorry. Let's continue. Access rows by index. We use iLock property. For example, import pandas, create the data frame. Okay, done. Create already. Second row. So we want to access the second row. So that we know that the second row is Alice, 28, and London. Right. Okay. So in order to access the second row, and we know that the index of second row is not 2. It start with 0, 1, and 2. So here John is 0, Alice is 1, Bob is 2. So your second row will be Alice, but the index is 1. So that's the reason we use df dot I location. Okay, I lock 1. Okay, so print the second row, you'll get this final output. Okay, next, get data frame index. We can access the data frame index using index attribute. For example, import panda, create the data frame, done, a return index. So if you want to return some index, df dot index, it create the first output. Can you see? If you want to return the values of the index, df dot index dot values. So it shows you the second output. So df index returns the index object. Df dot index dot values return the index values as a list. So this is the difference between the first one and the second one. Hope you guys can get it. Next, pandas array. An array allows us to store a collection of multiple values in single data structure. Pandas array is designed to provide more memory efficient and performance enhanced alternative to Python's built-in list NumPy arrays and other data structure for handling the same type of data. Let's see some examples over here. We can create pandas array using Python list. So we have import pandas, create a list first, data equal to 2468. After create the list, we create an array. So in order to create array, we call the method called pd.array. So the array is data. Okay. So this data will be passed the value over here and print the array 1. So you'll get here. So in this example, we are imported pandas library as pd. And then if you see the code array1 equal to pd dot array bracket data. So we have created an array by passing data as an argument to the pd dot array function. Next, instead of creating list and using the list variable with the PD array function, we can directly pass the elements. So how you can pass the elements? You don't have to create the list. You can directly declare the list inside the array. So pd.array list 2468. So print array 1, you'll get the same answer. So it shows you same output as the previous one. Okay, as the previous one. Explicitly specify array elements data type. So you can explicitly, which means separately, you can specify the data type for each array elements in your code. So import pandas. After that, we create the first one in this one is known as integer. Okay, PD array. This one is known as float because we have a decimals. This one is string, so we have string. And the last one is Boolean true false. So data type is Boolean. So this is how we explicitly, so we can separately specify the values. I mean the data types for each array elements. Create series from pandas array. So in pandas, we can directly create pandas series from pandas array. Okay, we use a series method. Okay, what is series method here? So we create PD array. This is from list. We create the array, right? So after we create this array, we actually can create series. Okay, a array series equal to PD series. Okay, we just call the array to become series. So when you call the array become series, you can see that it becomes index with the value. Okay, so of course the left column, this one is left column, this one is right column. So the left column is index and the right column is the values or data. Hope you guys can understand this part. Next, data frame analysis. Okay, this is one of the uh, quite important and significant part in Pandas, where, as I mentioned earlier, data frame is very important for data analysis, right? So in order to explore your data set, for example, your CSV file, your text file, or JSON file, okay, we have to use some built-in function called head method, tail method, and info method. So this will give you some inputs about the data set that you're using. Okay, let's go with an example. What is head? Head provides the rapid summary of data frame and returns the column headers and a specified number of rows from the beginning. Okay, so we have import pandas, create the data frame. Okay, we have name, we have age, name, age, city, and three columns. So we have created data frame, which is a table. Display the first three rows. In order to display three rows, first three rows, okay, we use df. So df, the data name, data set name, df dot head. Inside, we put three and print the output. So you'll get the first three rows. Okay, first three rows, and remember index always start with 0, right? So 0, 1, 2. So record 1, record 2, record 3. So this is the three first row in the data set. If you want to display the first 5 rows, okay, first 5 rows, you can just directly use df dot head parenthesis. You don't have to mention the value 5. Okay, it's automatic that if you put the method head, then it automatically gives you first 5 records. So you can see record 1, 2, 3, 4, 5. So total 5 records. Similar things apply when it's come to tail. Tail is considered the last 3 rows or the last 5 rows. Same records, same way of import, create data frame. df.tail3, last 3 rows you can see. Okay, total we have 10 records. So the last three records is start from 7, 8, and 9. 10 is not included, okay, because our index start with 0. So when you include 0, so total records are 10. And in order to get the last 5 rows, you just need to apply the tail method directly. Okay, df.tail parenthesis done. You don't have to mention 5 inside the parenthesis. So you'll get this answer. And then the next one is the info method. It's give you overall information. We know that information is information, right? So about the data frames such as the class, data type, size, and etc. So we create import data, create data frame, done. df. We want to get the information about the data, okay, the values that present over here. So df.info, once you create here, so it shows you how many uh, columns here. So call name, age, city, records with non-null. Okay, and there's no any missing values. So all presents records. And then the data type. It shows you the data type. First column is object, second column is integer, third column is an object. So we have one integer and two objects. And how much of the memory or the size, the space has been used for this particular column, 2D, two-dimensional or data frame table is created by 372 bytes. Okay, so that's all for first part. We'll continue a second part in the next video. Thank you.